Question number 4. Membrane potential. I want to remind you. Membrane potential is the difference in electric potential between the interior and the exterior of a biological cell, e.g. cardiomyocyte. What is the membrane potential? You have 30 seconds to answer. Answer: -89 mV. The relatively static membrane potential of quiescent cells is called the resting membrane potential, or resting voltage, as opposed to the specific dynamic electrochemical phenomena called action potential and graded membrane potential. What is the resting membrane potential? What is the resting membrane potential? Answer: approximately -93 mV. The resting potential can be calculated with the Goldman-Hodgkin-Katz voltage equation using the concentrations of ions as for the equilibrium potential while also including the relative permeabilities of each ionic species. Under normal conditions, it is safe to assume that only potassium, sodium, and chloride ions play large roles for the resting potential. There is no need to cram these equations, just know that it exists and can be used if necessary. For most animal cells, potassium ions are the most important for the resting potential. Due to the active transport of potassium ions, the concentration of potassium is higher inside cells than outside. Most cells have potassium selective ion channel proteins that remain open all the time. There will be net movement of positively charged potassium ions through these potassium channels with a resulting accumulation of excess negative charge inside of the cell. The outward movement of positively charged potassium ions is due to random molecular motion, diffusion, and continues until enough excess negative charge accumulates inside the cell to form a membrane potential which can balance the difference in concentration of potassium between inside and outside the cell. Balance means that the electrical force, potential, that results from the buildup of ionic charge, and which impedes outward diffusion, increases until it is equal in magnitude but opposite in direction to the tendency for outward diffusive movement of potassium. This balance point is an equilibrium potential as the net transmembrane flux, or current, of potassium ions is zero. A good approximation for the equilibrium potential of a given ion only needs the concentrations on either side of the membrane and the temperature. It can be calculated using the Nernst equation. Potassium equilibrium potentials determines mainly the resting membrane potential. The main mechanism for generating resting potential creating an asymmetry of the concentration of K and using a sodium-potassium pump, ATP, 25% RMP. The conclusion of K and from the cell through potassium leakage channels. Anions do not leave the cell. Other cations do not enter the cell.